Okay guys, so let's pick up where we left off in class. We're finishing the 8.3 notes. We're on page 3, starting with problem number 8. It asks us, what is the similarity ratio of the larger triangle to the smaller triangle in all of the previous examples? So what you need to do is look back at number 1. So flip back to page 1. Problem number 1, when we reduced on the left-hand side of those notes, when we did those little ratios, when we reduced them, we got 2 over 3. This is asking for the larger triangle to the smaller triangle. What we found was the smaller to the larger, so we need to reverse it, and instead of 2 over 3, we're going to say 3 to 2. Okay? Problem number 2. Those triangles are not similar, so there is not a similarity ratio. Not similar triangles, so no similarity ratio. Flip to page 2. How about example number 3? The triangles are similar by angle-angle similarity. We don't know any information about the sides. So just like in problem number 4 where there wasn't enough information, we just say that we can't tell. There's just not enough info for us right now. So leading into number 4, same idea. We have no idea whether those triangles are similar or not, so we can't tell if they have a similarity ratio or not. Problem number 5, these triangles are similar by side angle side. Again, we want the larger triangle to the smaller triangle. When we reduce this, we happen to put the smaller over the larger, so we have to reverse how it's written. We had 2 over 7. Smaller is 2, larger is 7. So larger to smaller would have to be 7 to 2. Problem number 6. Those two triangles, those were the overlapping triangles that we saw. Those two triangles are similar by angle-angle similarity. We don't know any information about the side lengths, so we can't say anything about the similarity ratio of the big triangle to the little triangle. We just don't know it, so we say we can't tell. Okay, last one, which is just above us. You can kind of see these guys right here. That's the one with those awful fractions, the mixed numbers that we dealt with, the 6/7 and the 1/7 that we did real quick at the end of class. Let's just move it down so we can look at it just in case you didn't quite get all that information from problem number 7. Okay, there's number 7. So we came out with, we did this in a weird way, right? So because we did the little short to medium to long. Excuse me. We ended up with 5 to 7 to 9. Okay, so we need to come up with, let's do one of the legs. So why don't we do an easy one? We knew these two. Those two were our nice numbers for the two sides, correct? We have an 18 and a 14. Big triangle, we want the larger triangle to the smaller triangle. So if we start with 18 to 14, those will reduce. Divide by 2. 18 divided by 2 is 9. You guys see that? No. It would help if I moved it like that. Okay. So if you divide 18 by 2, you get 9. 14 divided by 2 is 7. So the larger to smaller similarity ratio in this problem number 7 was 9 to 7. Okay. Number 9. It says the following pairs of triangles are similar. We need to solve for x. Okay. So it looks like we've got these two angles. That's how we could prove that they're similar, right? Angle-angle similarity. We've got two sets of angles marked congruent. So let's figure out, let's set up a proportion, and we're going to just do left to right. I'm going to go left over right. Okay, looking at these sides, what two sides do we know for sure right now that correspond? This 5 down here goes from the right angle to the 1 arc. There is nothing on that same corresponding side in the right-hand triangle, so we can't use that just yet. The 13 goes from a no arc to a 1 arc. From no arc to 1 arc is x, so we can do left to right 13 over x. But then we have a problem because the only other information we know in this right-hand triangle is this 9 up here from the right angle to the no arc. We don't have anything over here. And then this one we've already decided doesn't work because there's just not enough information over here. So we need to go back and look at the left-hand triangle. What do you guys notice? There's a 5 on a leg and a 13 on a hypotenuse. I'm giving you time to think. Oh, you guys are so smart. I'm so glad you came up with the triple again. It's a 5, 12, 13. They keep coming back. So if you still don't remember them, why don't you spend some time going back over them and remember them. Memorize them now. You're going to keep seeing them over and over. Okay, so if we are looking at the left-hand triangle, now we have this side length from the right angle to the no arc is 12. In the right-hand triangle, right angle to no arc is 9. Okay. The numbers aren't super huge, but they do reduce on the right-hand side. 9 over 12, you can divide by 3, you get 4 thirds. Makes it just that much easier if you just reduce right away. And you're not multiplying 9 times 13. Instead, we do 4 times x, you get 4x. 13 times 3 only, so we get, what is that, 39? Divide by 4, and you're going to get x equals, this is not a nice one, 39 over 4. If you do that in your calculators, I believe it comes out to a gross decimal. Let me just double check, but I'm like 99% positive it comes out to a gross decimal. Oh, I guess it's not that bad. It's 9.75. Really, you could put it as 9.75 if you want, or 9 3/4. Leaving it honestly like this is just as good. One less step. Okay, flip to the next page. Last two problems. Okay. On page 4, problem number 10, we have some overlapping triangles again, which means that we need to separate. So let's start with that. We're going to do little triangle and big triangle again. Okay, the little triangle, I'm going to keep it in the same orientation that it's on the page. This one's an X. We know that left-hand piece is a 24. Bigger triangle. It's not quite as pretty. Okay, easy side is the left one. It's a 36. It's pretty straightforward. The top, where we got the X from before in the little triangle, if you want that whole distance right here, you're just adding piece plus piece. So if we said this whole thing right here, it's just going to be 7.5 plus X. That whole side is 7.5 plus X. Okay, let's do little over big again. In the little triangle, first side I see is 24, or the same corresponding side, and this one is 36. So 24 over 36. We know that they're similar, because it's told us in the directions that they are, but we also see these parallel lines here, so we've got corresponding angles, so we know that this is going to work. Just as a side note, I guess. And then the top, little over big, so X over 7.5 plus X. Alright, 24 over 36, does that reduce? Sure does. If we divide by 12, 24 divided by 12 is 2. 36 divided by 12 is 3. So when you cross multiply, do the easy one first. Do 3 times X. You get a 3x equals the other direction. When you're cross multiplying and you have two terms on the bottom, meaning there's an addition sign and it's not just an x or a number. And you have to make sure that you're putting the parentheses around this guy. So it's 2 times this whole thing. So 2 times 7.5 plus the x. Distribute. You're going to get 3x equals 7.5 times 2 is 15. And then plus 2x. Yeah, x is on both sides, so carry the 2x over to the left by subtracting. 3x minus 2x is 1x equals 15. That's all we're looking for. It just said solve for x. Alright, last problem. I'm going to use pink, I think. Okay. We do know that this one is, we know that they're similar triangles. It's told us they are. We need to think about how we're setting this up, though. We're going to say it because the way that they're oriented on the page, it gets a little tricky. So call the one on the left, left. Call the one on the right, the right. And then let's just, knowing that we have some stuff going on here, we do need to just verify that they match, that the corresponding sides actually match with each other. So when we set this up, we know that these angles here are congruent, yeah, because they're vertical. So what I'm going to suggest is let's do short side over short side just to check. So we want to do our verify. What I mean when I say when you verify the matches, all you're doing is doing short side over short side, so 4 over 6, and then middle side or long side, I guess, because if you're looking at this triangle, that's the long side, over what we think is going to be the long side of this right-hand triangle. Okay, we want to verify that when we reduce these things, we get the same ratio. Okay, because if they do come out to the same, then those are the corresponding sides. If they don't come out the same, then those aren't the corresponding sides, and you have to do a little adjustment. 4 over 6 reduces to 2/3. Divide by 2. 10 over 15, divide by 5. You get 2/3. Okay, because they came out the same, we know that this side and that side are corresponding. They go together. We know 10 and 15 go together. Okay? So now we can set up our proportion where we're doing left over right. We're still solving for x. I'm going to choose the smaller two sides. So I'm going to choose 4 over 6. If you went with 10 over 15, that's fine. I'm going to choose 4 over 6 equal to left over right, 8 over x. Obviously 4 over 6 again reduces to 2/3. You get 2x equals 24. Divide by 2, x is 12. Okay? So your homework for tonight is 8.3. Tomorrow, again, just as a reminder, Mrs. Rachel and I will both be out. You're going to review for 8.1 to 8.3 quiz, which is what we're taking on Friday. We'll see you then.